Got another exam question walkthrough for the acids, bases and pH playlist. So we're on to number 20 now. If you want to check out the other videos in the playlist, I'll put the link to that at the top of the screen now. Hope you liked the video, hope you found it helpful, and if you haven't already subscribed to the channel, I'd love you to do so, but as always, the link to the questions in the description of the video if you want to try it first. Okay, so make a start. So number one, first thing I'm going to do is give the expression for Kw. So there it is there, Kw equals the H plus concentration multiplied by the OH minus concentration. So we've got to calculate the pH of pure water at 40 degrees C. So you'll notice I've written up there that in pure water, the H plus concentration equals the OH minus concentration. So that means we can simplify Kw to the H plus concentration squared. So if we want to calculate the pH of this pure water, we need the H plus concentration. So Kw rearranges to H plus concentration is the square root of Kw. So just sub in that value they've given us for Kw, and the H plus concentration is coming out at 1.709 times 10 to the minus 7. So we just need to minus log that for the pH, which to 2 decimal places is 6.77. So moving on to part 2, we've got some information about sodium hydroxide and hydrochloric acid. So we've got volume and concentration for both. So we're going to work out the initial moles of each of those, and then we're going to work out the final moles. So initial moles are coming out at 5.25 times 10 to the minus 3 for the sodium hydroxide, and 2 times 10 to the minus 3 for the HCl. That's obviously just concentration times volume in decimeters cubed. So you can see that the NaOH is in excess, so there'll be some of that left over at the end of the reaction. The HCl will go down to 0. So obviously the reactant in a 1-to-1 ratio, so 2 times 10 to the minus 3 moles of the NaOH will disappear, so that's why we're getting this 3.25 times 10 to the minus 3 moles at the end of the reaction. So because we've got sodium hydroxide left over at the end of the reaction, therefore hydroxide ions, we need to bring in the Kw expression, which we're now going to rearrange for the H plus concentration so we can get the pH. So that rearranges to that. You'll notice I've highlighted the two volumes there because remember these are moles, but we need the concentration of the OH minus ion to go into that expression. So we're going to take these moles here and divide by that combined volume, 55 cm cubed, but it's got to be in decimeters cubed. So you can see there the hydroxide ion concentration came out as that. So Kw over that is giving us an H plus concentration of this here, which all we need to do now is minus log to get the pH, which to 2 decimal places is 12.31.